So again, a welcome from my side to this webinar from the Greener Reefer Transition Alliance. It's our second one. And this time we will have also the honor to have an additional speaker on board. I will introduce them to you in a second. For the housekeeping, please let your microphone muted as well as your camera off as long as we have the presentations. We will go through the presentation and then you have also dedicated time for any questions and answers. If you have any questions in between, please let us know in the chat. We will take care of them in the meantime, but also to collect them. Thank you very much for joining. We have a very global crowd. So with this, good morning, good evening, and good afternoon. For the webinar, we have today highlights to have a deep dive into the economic case of reefers. So for those who are maybe new to the topic, reefers are actually maritime cooling containers designed for temperature controlled maritime freight, which means like any good, any commodity which needs to go from A to B overseas is actually transported by such a reefer. So there are now the big questions about the economic case. So what makes sense for shipping industry and also owners, shippers regarding the technology, where to focus on and what is the future holding for us. So we have a deep dive. This will be actually done by our colleague from the Kuehne Logistic University, Professor Dr. Gordon Wilmsmeier, who is also professor at the Universidad de Andes in Colombia. He will introduce the reefer emissions and cost savings simulator, also with some case studies. And last but not least, we will have also a little bit of information for you regarding who's the host for the Greener Reefer Transition Alliance. My name is Kirsten Orschulok. I'm the project lead of the Greener Reefer projects implemented by the German Development Cooperation Organization, GIZ. The project's running now for 2 years in close collaboration with the Kuehne Climate Center. And I'm very glad to have Mark Mayer with us on board, who will give you also a little bit more introduction regarding the topic. So after Mark's presentation, we will have then also the presentation by Professor Dr. Gordon Wilmsmeier, Kuehne Professorial Chair in Logistic Universidad de los Andes, School of Management in Colombia, and Director of Hapag-Lloyd Center for Shipping and Global Logistics, CSGL, at the Kuehne Logistic University in Hamburg. So for this, we can be curious for a very technical but very profound demonstration of the simulation. And also we have then the discussion with all of you regarding how to use it. With this, I would like to hand over to my colleague Mark Mayer, Senior Strategy Director at the Kuehne Climate Center, to give us a little bit more the overview about why this tool has such an importance. Over to you, Mark.
Thank you, Kirsten. Delighted to be with you today. I need to go on to the next slide. It seemed to happen. Yeah, and we're delighted to be working in the Greener Reefer Transition Alliance with GIZ and the Universidad de los Andes and other partners. And we're working together, we have been for almost 2 years now, on this opportunity for the use of natural refrigerants in refrigerated maritime containers, reefers, that are used in international trade. Next slide, please. Some of you may be familiar with this, but we can take you through it briefly. Starting on the top left here. So many of you will know that the refrigerants are being phased out. The harmful refrigerants that are very damaging for the ozone layer and very bad for the climate are being phased out on land under the Montreal Protocol. And this is happening at different timescales for different countries, but it's a clearly established phase down of these refrigerants. But at sea, in these reefer containers, they're still using refrigerants that are very damaging to the climate and contain these forever chemicals which are toxic to the environment and increasingly seen to have impacts on human health. Now, this is an interesting question. If you look at the bottom left, it's because the reefer fleet is growing quite dramatically. So there's several million reefers that are in constant use, providing us all with the fruits and vegetables and vaccines and medicine and chemicals and batteries that we all use every day. And this is a sector which is growing quite considerably with sort of 8% annual growth over the last decade or so. So not only do you have the replacement of the existing fleet, these reefer containers only last 10 or 12 years. So you need to have, if you think there's 2 million of these, you need 160,000 new ones just to replace the fleet that is aging. But then, of course, we have this growth rate. So something like more than 300,000 new reefers are needed each year, entering the fleet to maintain this growth and keep the fleet alive. Now, this represents an investment of something like $5 billion a year in new equipment. And the question that we're working on is that, of course, these reefers are still using these damaging refrigerants that are being phased out on land. So we're really looking at this opportunity for the sector to move to these new natural refrigerants. These natural refrigerants are widely available. They're used widely in cooling and heating applications elsewhere. So in cars, in heat pumps, in heating and ventilation systems that are already widely established use of natural refrigerants that are widely available, cheap, don't contain these forever chemicals, and also are not damaging to the climate. So this is the work of the Greener Reefer Alliance. And we see a real opportunity here for the industry to stop investing those billions in equipment which is going to carry on polluting and possibly damaging human health for the decades ahead, and move directly to these natural refrigerants. Next slide, please. So really, this comes down to a choice of refrigerants, right? And here in the bottom in red, you can see the natural refrigerants. And we produced a white paper last year, which sets out the technical case for all of these issues that I mentioned, the growth, the different technical options. And the current refrigerants like R134A and R1234YF, have each of these refrigerants have their own characteristics. Some of them have a very high global warming potential. Some of them are expensive. Some of them contain these forever chemicals. Different levels of flammability, and of course different costs. And we're comparing these currently used refrigerants in the sector with the natural refrigerants, which are here listed at the bottom. And we see a real opportunity for switching to R290, which is propane, or R744, which is CO2, to work in these containers. So, and these natural refrigerants themselves have different characteristics. So some of them have different global warming potential, but they don't contain, importantly, they don't contain these forever chemicals. One thing we have to bear in mind is that these refrigerants have different levels of flammability. So it's very important to look at the safety case. So what we're really looking at here in our work is the opportunity for the reefer sector to make a direct, swift transition to use of natural refrigerants and leave behind these polluting refrigerants, which are going to be damaging for years ahead. Next slide, please. So there's a broad consensus in the industry that they need to move to natural refrigerants. The question is, which refrigerant? Is it going to be propane or is it going to be CO2? And when is the right time to make this transition? And this is exactly the work of our alliance. We've been looking into these questions. The technical feasibility is key. In GIZ, are developing a prototype, which is being lab tested so we can understand the physical characteristics of such a container, its energy use, for example. And importantly, we need to prove that it's safe. This is the safety assessment, thinking through all the different cases of using this in ports, on farms maybe, on the ship, and all the different safety cases around that and the mitigation measures that need to be taken to make sure it's safe. Has to be serviceable. I mean, we need to make sure that people are trained to handle these new refrigerants when they turn up in a port. So with GIZ, they've been developing and testing a training program for technicians to show that we can upskill technicians to handle these. But then an important part of this story is the economic case. Is it affordable to make such a transition? This is the fourth element of the case that we've been trying to explore in the Alliance, and that's what we're focusing on today. So we're very happy to have worked with the Kuehne Logistics University and the University of Los Angeles to develop this simulation tool so we can really understand the economic case of making this shift. And that's really what the focus of the webinar is today. So we're already working on these other three elements: the technical feasibility, the safety case, and the training of technicians. And this is the fourth element, the economic case. So yeah, looking forward to, I've seen the tool already. I'm looking forward to seeing the final version now, Gordon. Yeah, I'm looking forward to the questions ahead. So that's a little bit of the introduction, Kirsten.
Thank you very much. And again, here, if you have any questions, please post them in the chat. Also, if you have questions to Mark, especially. But later on, we have like a dedicated time to answer all the questions which are arising. So now over to you, Gordon. As I mentioned in the introduction, you're a professor in Hamburg, but also in Colombia, which is like a huge benefit also for the tool to have like also this reality check and bring in like different perspectives. And also when we first started to work together, you introduced yourself to me as you're the port guy. So therefore, even better to have like this very specific knowledge and deep dive now into the tool, which is for free online available. I will also post the links in the chat and also all the slides you will get after the webinar. So Gordon, over to you.
Okay, thank you, Kirsten, Mark. I think you can see my slide.
Yes.
Yes, so perfect. So yes, so thanks for the kind introduction, and pleasure to be here. And also, yeah, good morning, good afternoon, good evening to all of you that are with us. And I will use, I think, the next about 30 minutes to talk a little bit about what we did, building on this very interesting work the Greener Reefer Transition Alliance has been doing in looking, okay, how could a prototype look like, what refrigerants could be used, and then we have accepted the task to say, okay, but what happens if we then bring them into operations? What happens if we put them into the shipping context? And how could we simulate this, and then also try with this to inform different stakeholders that might be interesting in this transition? So what did we do in the tool with our colleagues at the center? We said, okay, what are the parameters that are relevant? Because if you work in the reefer business, we know each product also has different needs and expectation in terms of refrigeration. So it needs different conditions. Also, containers can be different in terms of size. And we also knew that the vessels which they are on are different, and the routes they're using are also different in terms of their conditions. So we said, okay, let's try to bring these elements together and try to bring, on the one hand, a breakdown on what would a use of these alternative refrigerants mean in terms of greenhouse gas emissions and PFAS, and what would it also mean in terms of the operating cost, particularly focusing on here the cost of energy that is going to be used when operating these containers. So, and the other thing we were also interested in is, okay, what happens if we think about the CO2 abatement, and if we think about of CO2 prices, would that also make a significant impact in the attractiveness of the use of these natural refrigerants? So we looked at indirect emissions, right? That means from the operation of the reefer container in terms of the fan heat, the evaporator, the ambient heat ingress, respiration, etc. And we looked at the direct emissions, looking at the global warming potential of also refrigerant leakage, obviously in this sense, and the PFAS, so the indirect chemical emissions in their risk to that. Now, what did you try to answer? Okay, first of all, obviously, what would be the CO2 footprint per container for a given route if we use alternative refrigerants? How much would that make a difference in terms of the current operations? And then how do they then also compare in terms of emissions and costs for that? And then in the end, it's about this comparison, right? What is the trade-off between environmental performance and operational expenses in this sense? And when can we make a case study out of that? So we try to bring this as close as possible in the simulation tool as to real world transport scenarios. So I'll give an introduction about the tool and then leave one particular case study with us. Now, we figured out who is this interested for and who would benefit it. Obviously, logistics operators may be interesting because they are also selling products, and clients are interested, okay, what is my carbon footprint if I use a reefer container? So it can also help in informing about what is the carbon footprint of my supply chain potentially, particularly if I use an alternative technology. It can also be interesting to shipping companies, clearly, because they are the ones that buy and build reefer containers. So what would that be a benefit for them? Policymakers can support these decisions also in terms of promoting the use of alternative refrigerant, and obviously us as researchers as well. Now, so what do we have in the tool? On the one hand, we have certain input parameters, and I will go through them. We have you can choose certain product parameters. So, what type of product am I moving? Am I moving berries? Am I moving pharmaceuticals? Am I moving maybe bananas or cherries? What are my container parameters? Do I have an IQ or 40-foot? What type of container do I have? What type of vessel do I have? Which vessel am I using? Again, you would see that because we're also trying to simulate the emissions along the route, and also then looking what is the relationship between obviously the vessel emissions and the ones that we can actually allocate into the reefer containers. And we also know that the route will be important, and there might be certain routes with certain products, and that's one of our hypotheses that might be more it's interesting in the beginning to do this transition towards alternative refrigerants than others. The other important part for us was, okay, if we take the different prices of the refrigerant as well as the fuel, these will also impact on the competitiveness of such solutions. And then in the scenarios, these are our case studies. What we then do in the simulator, we allow a comparison in terms of emissions, of operating costs, CO2 abatement costs, and you can then compare between the different types. So let's dive a little bit deeper. So as I said, the characteristics of the imported product were imported, then the operational characteristics of the reefer container as well. For example, leakage rates, for example, we can set the vessel. Is it what is the reefer capacity of that vessel? How many reefers can it load? And then the voyage conditions, right? What is the maritime route? Again, I'm going to dive a little bit deeper in that. Am I going through an emissions control layer or not? And the prices, we look at different price scenarios. Okay, so let's look in here. So, as I said, it's about the environmental performance of the refrigerants used in the reefer, the energy performance of the reefer container, the economic results in terms of cost of the energy cost being used, and including also the CO2 abatement cost. Then the comparison, and we have some case studies, as you will see later on. Okay, so let's go into the case study, and you will then have more insight. What can we choose in this? So we took this case about banana exports from Ecuador to Hamburg as a case, using a specific vessel, because we thought this could be a good use case that's interesting for many people. So what are our input parameters in this sense? So first of all, we have obviously, we set the temperature, we have a certain cargo heat production, and we have the fan speed, which just has to do with the conditions the cargo needs. And so in this specific case, we use a temperature of 14 degrees, right? So it's a special chilled kind of transportation type. And we have a certain heat production, which has to do with the respiration of the bananas. Here, like linking this to the general options in the simulator, you can then obviously, if you have a different product, you can then adjust these parameters to what your product might be. So that is whether it's berries or other things as well, right? So then after the product parameters are set, we then set the container parameters, and that's quite interesting because here we also start to enter the reefer technology and also the conditions of the reefer and how the reefer works. And this might be particularly interesting for people that operate the reefers, right? So, okay, what is the cargo that I'm moving? What is my ambient temperature, right? in average on that I will have? What type of, will I use high speed of the evaporation fan power or low speed? How much is the energy consumption of that? That can also be interesting. If I have a prototype, I can put in new values and adjust these values. How much refrigerant do I have to put in per year? What is the leakage rate in terms of that refrigerant? Quite relevant as well, because that will also have implication in terms of cost that I have. So these I can use as a baseline, the parameters we have set in. This is what we have taken from the results from the Greener Reefer Transition Alliance, what has been coming out of this. So we take this and here we use a 40 feet high cube container. Then we take the vessel, look which vessel we'll use here. As I said, we chose a vessel built in 2017 with a certain capacity of almost 4,000 TU and 2,000 TU reefer capacity, and we choose an average operational speed of 14 knots and a little bit more. Interesting here, what you can also then put in, what are the vessel fuels you're using? Are you using IFO? Are you HFO? You can adjust that as well, and this will help you in the simulation. And you can also, we give some reference value for the fuel consumption during the voyage as the speed or the fuel consumption in port, which is then related obviously to the auxiliary engine power, right? And what is the other fuel consumption in port during that stay? So this is also then you can be very specific here or more generic, depends on what you would like to do. As we know, the voyages can be quite different. So, and the energy consumption on the ship will be divided also by the cargo that is actually loaded. So I think an important parameter to choose from and you can play with is what is actually the capacity utilization of this vessel. Because if I want to break the emissions as well as the energy costs down per container over a certain period, I will obviously have to that in relation to the capacity utilization. Then we take a specific service that we choose. We have a distance. We set a number of voyages per year that we might have and the trip duration in terms of days, how many days are in port. And then the important thing that we also added, we thought was interesting is, okay, if the vessel travels in self-emissions control areas, it might have to change its fuel, or it will have to change fuel depending on what fuel it uses in the beginning. Then also this will affect my voyage energy cost. So here again, we are also accounting for that. We can also, if one is interested, you can say, okay, actually my vessel is capable of using onshore power supply. Then this would then we would take a reference value for the electricity cost and the electricity used connecting the vessel to the shore, also accounting for these possibilities, how that might affect your energy costs in operations. All right. A key element was then what are actually our prices that we want to compare and that might affect our operation. So we give some reference prices for the fuels that the vessels will use. And we also use reference prices for the refrigerants. And you can already see, which is quite interesting, that actually the two natural refrigerants, propane as well as CO2, are significantly lower in price per kilogram if you purchase them today, right? So this already shows an advantage. The interesting is, why did we include the prices? Because it also helps us to build scenarios. What happens if for one reason or another, the prices of propane or CO2 would increase significantly in the future? Or depending on your route, I have different prices. So that might also affect the attractiveness of using the alternative refrigerant. So here again, bringing this operational and energy cost dimension to it. And we put a carbon tax per ton of CO2 emitted from the operations into the equation as well. All right, so let's look at some of the output indicators and staying with this case study, because we figured if we stay with the same case study exemplifies quite well what you can do maybe with the tool then in your own simulation. So clearly, then we compare, as you can see also in the tool, between the traditional refrigerants and the natural refrigerants, which are in the darker blue, right? And you can see that the emissions are obviously dominated by the indirect emissions, which is the energy use, and the direct emissions, right? This particularly relate to the leakage impacts, which we have from the refrigerants, right? And we can see that we basically eliminate those, obviously, with the switch towards the natural refrigerants. And the same obviously accounts then for TFA emissions, right? Which basically are eliminated through this switch, and we can clearly then show this contribution here very clearly when it comes to that part. Now here we're only looking at the GHG emission from the refrigerants in reefer containers per container trip, right? This is so we are not looking at the whole voyage emissions. We're going to come to this in a moment. Then, which we also figured, okay, let's take also the vessel emissions into account, right? So again, here we do a comparison of GHG emissions per reefer container per ton nautical mile. Again, we can see obviously in the whole voyage context, then these emissions, the direct and indirect emissions for the reefers, then are not that relevant. The main emissions are still from the vessel en route, right? But again, we can see this little advantage that each reefer that we move with natural refrigerants will contribute, right? So, and it reminded us a little bit of the discussion when we talked about, okay, emissions in ports, in supply chains. So how relevant are emissions in ports and supply chains? Well, a lot of people argue it's only 2% or even less. But again, here we have a similar case. Each gram, each kilogram of CO2, each gram or kilogram of TFA we can eliminate, obviously is a contribution towards that goal that we have. And they even kind of show up in the relationship when we use the full route and we use all the energy consumed and emission that are generated on that trip, right? So there we can clearly show this contribution. And here we included the vessel emissions as well, because as we said in the beginning, it is important also, okay, what type of capacity utilization do I have on board the vessel? And also it will have to, the vessel characteristics are relevant. Obviously, during my port, say which type of engines can I use to have onshore power supply while I'm at port? Or is the vessel actually running on methanol, or is the vessel running on LNG? So we can also obviously then take this into account and we will get some results for that. All right. So then if we look at the cost, and here it becomes quite interesting because here the difference increases a little bit. So here we have the cost for energy and refrigerant per container trip calculated. Again, here it becomes very nice, this economic advantage that we found in terms of the energy cost for the natural refrigerant. And we figured that can be attractive for the shipping companies because it will obviously reduce their costs as well. But it's also interesting for the shipper, right? Because they can probably, even if some of these cost savings are passed on to them in the freight rate they pay, they always can get a benefit out of that. So again, we can see a nice benefit here in terms of savings per container nautical mile and per container trip. So we really try to break it down to a value that's comparable. The values are quite low for US dollar per container nautical mile, we know. But again, if you think about the thousands of kilometers a reef container might travel, then we become interesting values in this. And it actually might be quite relevant for the overall cost in the supply chain. Because I also remember a lot of discussions we had in Ecuador, actually, when it comes to how a certain number of dollar cents in, for example, transport costs in the hinterland already affect the competitiveness within the supply chain at a global level. All right, so let's look at some some cost savings per container per year. What can we see? So here we take a comparison of propane with the others, and we can clearly see the superiority of propane in terms of cost savings per year. And again, here we can see it in comparison to the traditional R321A, R334A, right? We have a cost saving of about $370, $380 per year. And it's not that much, one could say, but if you think about the numbers of containers that circulate and the number of containers you might operate in your fleet, it starts to become relevant. We can develop, and again, this is specific. I should stress this is specific for this case of bananas, right? If you use a different route, if you use a different setting, a different setting also of leakage, that might change, right? We see obviously a similar situation, as you can guess from the previous slide, when we apply CO2. Again, we have this cost saving and can make use of that. Again, you can turn it around. This is also showing a little bit the functionality of the tool that we have. That here then we use the traditional refrigerant, and we can see actually that the natural ones are superior. So again, these are these comparison the tool allows and allows you to play with. All right, so then what about the CO2 abatement? Because yeah, and then we clearly see, yes, we have a benefit here in terms of CO2 and propane, particularly in propane, where we actually have this savings what we generate, and also this is always thinking about what happened if we were to pay for the CO2 emissions per ton, what savings could we generate? And basically, it would be an avoidance of paying for a ton of CO2 emitted. Okay, so what other case studies did we develop to kind of show the heterogeneity also in the sector? We looked at battery transfer from China to Rotterdam. We looked at cut flowers from Kenya to Europe. Transport of berries from Chile to China, and some pharmaceutical products from Baltimore to London with different vessels. Also using an LNG vessel to show this. So these again are specific case studies which we thought could be interesting. So we invite you also to have a look at them and read them up. But this is just to simplify what the tool might be able to do and how you can explore that in depth. So what are some key findings and some key takeaway? So yeah, we clearly have strong reductions in direct emissions. We have reduction in indirect emissions. This is basically confirming that work from the Greener Reefer Alliance, what we know. So we replicate that. We have the elimination of PFAS and TFA emissions. But the other interesting relevant here is the significant reduction of operating costs depending on the refrigerant price and how that can be simulated and how that can maybe create an argument for the attractiveness of a transition towards this new technology, right, which is now starting to be built in trial. Because obviously, if there is an economic benefit as well in implementing, the market might be more attracted to taking this up as well. And we also can show that when you play and start to with the different parameters and routes, you can also find out in terms of your strategy, okay, in which route for which product I can maybe reap the greatest benefits of applying this new technology, and which might be the most relevant ones also for introducing that, or where can I provide more cost competitiveness also for my shippers if I start to implement this new technology once it's on the market. So we found it particularly interesting how here we have this combination of lower environmental impact of the new technology and a potentially improved competitiveness. And for the shipping lines, probably a more competitive product also in cost and not only in environmental performance. And for the shipper as well, maybe improve competitiveness, because if some of these energy cost savings can be reaped and or taken up by the shipper or passed on by the shipper, obviously it might be relevant in terms of being competitive in comparison to other markets where this technology is not in place. All right, so any questions we're happy to answer, to discuss now with you, and looking forward to your comments and questions. Thank you very much.
Thank you very much, Gordon, also for the deep dive and also for the case studies. For those in the call, Christian is also here in the call and can answer further questions regarding the tool. I would like to open the discussion round, as I have not seen yet other people coming forward, but maybe this will change also in a minute. So you shared about like the different examples from the case studies, for example, the bananas from Ecuador transported to Hamburg. Can you give us like a little bit more ideas regarding who could be able to use this tool? As we also posted in the chat, there are 2 versions available.
So as I mentioned, I mean, I think one obviously is hopefully also shipping lines, right? We talked about the shipping lines being the one that purchase new reefer containers. They might be using, looking, okay, how could different routes that they use today, how could that pan out? But we also figured that it is really interesting for cargo owners that look for this competitiveness within their cold chain, where maybe a few cents of a dollar, right, define if my product, whether it's my berry, my banana, is competitive or not. Particularly when it's more commodity-like products, like bananas, right? Because we know there is a very strong competition, and then it's also the question, okay, who is the owner of the reefer container? Is the shipping line the owner of the reefer container, or am I the owner of the reefer container, even maybe as a cargo owner, right? Then if I own this type of container, I can also benefit economically from this. So I think there's also quite an interesting argument into looking into this. And we shall not forget that these energy cost savings, we now looked at the maritime leg, right? What we didn't consider in the simulator is what happens when the container is stored at the terminal, right? What happens when this container is stored at the farm or on a truck, depending on how long these distances are. So these savings we showed in the energy cost on the maritime leg, they can probably also be replicated along the whole supply chain, right? From the farm all the way to the final destination. So I think that there's an interesting argument here as well.
Perfect. Thank you very much. Also to have like a little bit more elaborated regarding the different possibilities for the users and how to use the tool. I have another question, if this is also right for the audience. Please again come in, raise your hand. You can.
There are
also
2 hands. I see 2 hands.
Perfect. Yeah, no, that's good. My Zoom somehow did not help me with this.
Okay.
Perfect. So I have one hand by Pauline Ugwalu. I hope I pronounced your name correctly. Please come in. Followed then by Kevin Njau.
Thank you.
Pauline, you're muted again. We just could hear you. Yeah. Now
Sorry.
Yes,
yeah.
now it works. Perfect.
Perfect. My name is Pauline Ukwalu. I work with KCC as a assistant junior or junior project coordinator. I wanted to speak for the case of cut flowers from Kenya to Europe, and just speak to the current environment when it comes to reefers. You find that when it comes to reefer containers being moved from, for example, EU to Kenya, there's a markup cost, and this is because most of the reefers come to this side empty, and then now from this side they are taken back with either flowers, avocado, or vegetables, and that is something that has been adding up to the cost of the rivers. So I wanted to know whether we are taking those considerations in in place and coming up with a general solution that can allow even these reefers to be used for other cargo. One of the challenges has been that there's no technical capacity to allow the power takeoff maintenance from this side. So we are not able to bring in these reefers with general cargo or any other type of cargo. And I see that has an opportunity to shape that and address that challenge and also lead to further reduction in cost. Yes, I would like to hear if that is something that is being taken into consideration as we bring up solutions for this.
Okay, Pauline, thanks for your question. I think what is important here to stress and differentiate about the cost. Here we are looking at operating costs of the reefer, not the price we pay in the market, right? And so this is a very important differentiation to do. We clearly know that in the reefer market in general, the imbalance of reefer containers and cargo puts a strain on many of the supply chains because these repositioning costs are somehow included in the reefer prices we pay. But again, in terms to our work, what we do here, what is relevant, if there is a cost reduction, right, in the operations, these cost savings might be passed on, right, in the market conditions towards the user of that container, right? But it also means if you're an informed user, an informed exporter, you might specifically ask a shipping line to have in the future, right, to have a container with a new technology because it will incur lower costs. And the other thing is, if you are reporting the emissions in your supply chain, that would also be then a benefit for you because you could inform your carbon footprint that would be lower. That might lead to a great attractiveness, in your case, of flowers in the destination market because they will have caused less environmental impact, right? But it's important really to differentiate clearly what is cost, operating cost, and what is the price in the market on freight rates.
Thank you very much, Paulina. I hope also your question was answered. So I would like to continue with the people who raised their hand and then go over to the question in the chat. So everyone is, of course, seen and heard. So then I have Kevin Zhao first and then followed by Sadak Agarwal. Please.
Thank you so much, Kirsten. Thank you, Gordon and Mark, for your good and great insights. I have a question concerning the low carbon shipping fuels. So as you all understand that one of the solutions to decarbonization and to lessen emissions is the particular application of green methanol or green ammonia, including hydrogen. And I'm led to think of what then would be the impact of the economic case for natural refrigerants, the R290, R744, as we move away from the synthetic refrigerants. So what's the economic case for that?
Okay, what's the good question? Actually, the case would be even greater, we have to say, because if you think about that, the alternative fuels are more costly per ton when you purchase them, right? And the new technology is more efficient in the energy consumption. Then you would actually have a bigger differential in that cost, right? So this means there's maybe an additional argument when you use alternative fuels or more costly fuels, that the equipment that you have on board the ship or that you as a ship are using is the most energy efficient possible, because that will reduce your cost and attributions in the sense, right? So the gap would be wider and the savings would be greater. So for us, this is an additional argument why, particularly with the transition towards alternative fuels that are more costly, this could be an additional benefit for using that new technology.
Thank you very much. And great, also see the question was answered. So over to you, Sadak Agarwal. And then we go over to the questions in the chat.
Thank you, Christine, and thank you, Gordon, for a wonderful presentation. And I think this is really a useful tool. I had a question regarding the graph that was mentioned for yearly cost savings per container. So I see some negative values for propane and CO2. Now, these cost savings are because of less fuel being consumed for these reefers, or they also include the emission tariffs that might be not paid because using of these fuels. So does it include both, or only fuel cost?
It includes the simulator includes both. You can include the CO2 abatement costs. So right, we set it at $200 a ton. But you can also then, and the rest is attributed to the differences in the efficiency of the technology, which we have from the technical information which we used, and obviously the difference in the price of the different refrigerants as well. Right. The cost differential also emerges. Remember when we talk about the reefer. So one thing is obviously the energy consumption, but also when we talk about the reefer, we have a certain level of leakage. Right. We have a regular refilling of the refrigerant, and obviously the cost differential in the refrigerants will also attribute to that cost differential over the years.
Okay, and all of this can be done via the tool itself.
Yes, you can play with that. Yes. As we said, there are two versions. Sorry, Kirsten asked that. I didn't answer that actually. Kirsten asked that. We have one version where we set more standard values, and we have like an expert version where you can basically play with any of the parameters. But we separated the versions because it can be quite confusing. Because there's a lot of parameters in the modeling, and in order to make a real comparison, you kind of have to have a very good knowledge on what you want to find, right? So obviously you're invited to play with that and also come back.
Okay, thank you.
Thank you very much for the question. Again, like after the webinar, we will share, of course, the slides, but also again the links so that you can also download the different tools. We have two more questions in the chat and also a comment by Francisco. So I would suggest first we go through the questions and then also shed a little bit light on the comment regarding one of the case studies. So the first question I would take for the energy efficiency. So Castro asked regarding the try comparing of the electrical consumption with CO2, propane, and R134YF, and regarding the electricity consumption in kilowatt hours. So currently, with CO2, there's one product in the market already. It's from Carrier Transicord, the natural line. Their consumption is quite high as CO2, although it has so many good benefits for a sustainability perspective and also for environmental aspects. Due to the chemical composition and also how it is behaving as a refrigerant, it is a transcritical refrigerant, which means it needs 2 cycles and therefore higher energy consumption than in comparison to the current used reefers in the market. So I assuming it's around 4 kilowatt per hours, but I have to check. But again, this one is already in the market. For propane, the product is not yet in the market, but with the lab tests, we can prove that it has already 10% less energy consumption in comparison to R134A, which means just by using this refrigerant, which is also cheaper in the buy-in, the engines are, besides some compressor changes, already more efficient than the current widely used, like by 96% of the market used refrigerant. There are more details in the white paper. You're more welcome to check it out again. And when it comes to R134YF, these are like the newest units in the market. So of course, during the whole development, so the reefer market itself and the development, they was super progressive. So the energy savings are tremendously raised, or the efficiency gains in the last years. So the current unit, I think it's now in the market for 1 year from MCI, I think has a kilowatt hour consumption of 1.5 to 2, depending on the use case. There are also the other competitors. So we don't do any advertisement. So it's like besides MCI is Carrier Transicold, Thermo King, and Daikin also working on YF units, or will bring it soon into the market. They're all around 2 to 2.5 probably. So again, propane, if they would be used in this newest version of the optimized version of the reefers, maybe also have 1.5, but we don't know it yet. And again, the propane unit is right now under development. That's so far for the energy efficiency. So again, it's like also a compliment to the reefer industry that they are working so hard to reduce the energy consumption, but still, and this is also one point, the main industry owners, so which are like the main shipping lines, their perspective is actually for 5 years or up to maximum 8 years of the use of reefers. So like always the newest containers. But we should not forget, also in the perspective of the Global South, reefers are in use for actually up to 20 years. So this is like our information we got from our colleagues in South Africa. So even if like the main use, they are selling these units with the not anymore high performance of energy consumption, but they are still using globally. So this is also always important to have this in mind, that these units are not out of use after 5 years after the first owner sell them. So they have this 20 years perspective, and this is also then coming to the YF discussion with PFAS. These refrigerant is then still out there, although maybe they are not anymore used by one of the main shipping lines. So then it's the question what to do with them. Where is the recycling setting? What is the impact by the YF units, who can maintain them, etc., etc. So there's a long question which are like not in the focus of the main users for the first 5 to 7 years. But again, there is more information in the white paper, where we also will publish soon the Spanish version of it, also for our Spanish-speaking community here in the call. We have another question regarding propane, and this I would like to give over to Mark for answering.
Thanks. So indeed, propane is flammable. So the current refrigerants used in reefers, like 134A, are also flammable, but propane seems to be more flammable. So this is a real issue in looking. This is an option. Propane, of course, is flammable only under certain conditions, certain temperature and certain pressures. It seems to be the case in the discussion that leaks of propane outside the reefer is not really an issue, because, of course, this is tremendously dissipated with the atmosphere. So then the focus in on the leaking inside in the container. So then it's a question of how likely is such a leak likely to occur, and what volume of propane would be leaked. Okay, so the new versions of these containers have very, very small volumes. So they're really trying hard to reduce the volume of propane that is in the system. So this would be one effect. And then the other aspect is the capacity of the fan within the container to exchange the air. So if you have a sensor which can sense as a leak of propane, then of course you can turn the fan on, and in less than, I think it's in 40 minutes, you can exchange the whole volume of air in the container. So of course, that's one mitigation measure. The other thing that they need to be considering is the chance, what is, if the propane leaks inside the container, what is the chance of a spark occurring with enough power to ignite it? So that's another aspect that I need to look into, is what is the chance of such a spark with enough power occurring? How could that happen? One discussion is this, like friction between certain types of packaging could lead to a static spark. So these are exactly the things that have to be understood for the risk case, and what are the mitigation measures. One option, for example, some people think that a dual system where you only use propane outside and then there's an exchange to another refrigerant inside the container. That's one solution. As I said, the sensor and then turning on the fan to dissipate the propane is another option. But all of this needs to be understood, like all risk, in its comparison with other kinds of risks. We should remember that there's lots of very, very dangerous chemicals being carried on ships and containers already. So, ships and ports are used to handling dangerous, reefer containers carry propane themselves. So, then there's quite significant amounts of propane. And also the other thing to think about is that propane is widely used in refrigerant applications, like in a fridge, in your kitchen. Are you really concerned about the explosion risk from the fridge in your house? We use propane for cooking at home, so we literally have it connected and we light it and cook things with it at home. So this is, another thing. Many people have a barbecue that runs on propane and they're not too worried about it. Have 5 kilograms of propane in their shed, and that's common, but people don't worry about it. So you need to see this in the context of the real risk assessment, which is very important and needs to be done in detail to provide, before you can get a safety certificate and run these on a ship.
Maybe then also there are some follow-up questions to this, Mark. So one from Alan regarding the subject of flammability of propane. Is this not only already addressed in passenger transport, for example?
Yeah. Propane is used in the rail industry. So this, the rail industry uses propane, and those trains are running through cities. Those trains are carrying dangerous goods. Those trains are running through tunnels under the Alps. So absolutely, these risks around the use of propane and refrigerant have even been covered in supply chains in quite critical circumstances. So this work absolutely needs to be done. But yeah, it seems to be that the risk is limited to some circumstances, and there's a number of mitigation measures that can be taken.
Mm. Thank you so much. And yes, so there also I would make like a little advertisement blog for the Green Cooling Initiative website, where you also see like other companies working with propane with different areas. This is like from the GIZ side. There is another question also follow up regarding how much propane should we expect to have in the reefer, which we are working on. So this is from Louisa. Mark, shall I answer, or would you like?
Please go ahead. You know that.
Yeah, sure. So right now, we have in the current laboratory setting, the reefer is using less than 2 kilos of propane. So we could dramatically reduce the charge, because currently reefers are running with around 5 kilos of refrigerant. So this is already like a reduction of the mass. Again, we will show the prototype itself during the Hamburg Sustainability Conference in end of June. And I'm not sure how much more I can share, but of course there's from the shipping industry also the expectation for the reefer, if it would be less than 1 kilo of propane, then it would be also safe. This is like an ongoing back and forth discussion regarding how much safety is acceptable and needed, but also how energy efficient should the reefer be, because then there are like different technical solutions. Mark already mentioned like the secondary loop or cascade system, which would need more energy efficiency, but then there would be no propane in the box. And this is right now like a bigger discussion between the shipping lines, so the customers of the reefers who would buy them, and the OEMs, so the manufacturers, who are saying like from a technical point of view, it would be possible. So it's beautiful to have this collaboration under the Greener Reefer Transition Alliance together with the Kuehne Climate Center, and then to have also this example as the simulator with which Gordon presented, to bring in more knowledge into the discussion, to have a more educated decision. What is the future? Where's the way forward? We have one last comment actually for one of the cases, Gordon. I know you have seen it already.
I've seen it. Yeah, Francisco, thanks a lot for that comment. And obviously that was our academic freedom to use particularly this vessel, because there has been a lot of discussion about the case that happened about this time last year, about 12 months ago, right? And obviously those we have to argue are exceptions, right? Should not occur during general operations, and a lot of these losses, if these type of failures appear with the vessel, they are obviously covered by insurance, obviously. So here for us, it was really okay if under normal, regular operational context, what are the savings, right? Obviously, it shows very clearly the example you state, how much money is at stake when we talk about the reefer market, and how important it probably still is to make savings along the supply chain. Whether it's in the equipment, whether it's in the energy consumption, but also to avoid CO2 costs, right? So, yeah, what else should I say to that? it is an interesting example, but we are here looking at the general operations within Reefers. So I hope that answers your question. But and if you have a good idea at CBS and you want to develop a simulator that also includes operational risk and disruptions and the effect of that, you can reach out. We're happy to discuss that with you.
Perfect. Thank you very much. For those who have not seen the comment yet, so Francisco pointed out that the case study for cherries on a Maersk Toro vessel from Chile to China is not kind of a good example because the vessel experienced an engine failure and was carrying around 1,353 reefer boxes with cherries, which are completely destroyed. So it resulted into a loss of 150 million due to the cherries were not anymore sellable or eatable. With this, at the moment I do not see any further questions or raised answers, but also thanks to Mark for sharing already the links on our LinkedIn connections for the Greener Reefer Transition Alliance. You are more than welcome to follow us. We will have regular updates also about the next webinars and our activities, as we are also working, for example, in Costa Rica and South Africa for training of technicians. So there will be regular updates. We just have been at the Fruit and Logistica last week, so there we will also share more information about the discussion and ongoing process. I mentioned already the Hamburg Sustainability Conference end of June, where we will demonstrate the prototype, also the safety concept, so that it's running. Again, thanks also for the highlight that the discussion around propane was already solved or is solved for passengers transport. So there should be a way forward also for the shipping industry to find a solution which is acceptable between the customers and also the shippers and the OEMs. So we are quite lucky in this position to trying to facilitate and also to bring in all the education and now even to have a simulator for the economic case about which refrigerant could be used. But of course, you're more than welcome to use also the other indicators to play around to see what is feasible. You see here our contacts for the Greener Reefer Transition Alliance. Again, we will share the slides as well as the links for the basic and also kind of expert version of the tool via email if you have not seen it yet in the chat. And please check out the white paper. Again, we will announce soon also the Spanish version. Have a deep dive into it. And also, as Gordon mentioned, he is also open for follow-up questions if you have any, or just to stay in contact with him. With this, also I would like to thank the team, so also Christian and Silvia for supporting this webinar. The next one will be probably on training with technicians with the head of the training center in South Africa we are collaborating with. So stay tuned, look forward to our next discussion and reaching out to you and follow up with us to have a more and better vision regarding which refrigerant should be the future of the reefers, which is, of course, from our point of view, a natural refrigerant. Thank you very much with this and looking forward to our next occasion to talk with all of you. Thank you.